Okay, so 6.2 inverse functions, we're going to be looking at 3 different types of things, and you want to compartmentalize, because when you get to your quiz on Friday, and we get to your homework, you've got to know how to do certain things at certain times, and I want you to be able to sort of keep them in their categories, and so you know when you have this kind of problem, you do this kind of thing, when you have this kind of problem, you do that, and so we're going to break them up into those categories today. And for your homework and for your quiz, I want to just make sure that you know how to apply the right process to the right type of problem. Okay? So, the first type is really simple. Okay? And that's when you have a relation that's a set or a function that's just a set of ordered pairs. Okay? In reality, what inverse functions are just exchanging the x's with the y's. So if you happen to have a function that is just a set of ordered pairs, and this is back in chapter 2 we talked about relations, a set of ordered pairs, and a function was a special type of relation. Each x only had one y, or maybe you remember that. To find the inverse, you just exchange the x's and y's. So here's an example. So here would be an example. Here's a function. It's a set of ordered pairs. Each x only has one y. The inverse of this function is just a set of points where the x's and y's are switched around. So go ahead and write that out. Write the inverse of those. No, this is not the whole lesson. Again, so when you're given a set of ordered pairs, inverse is found by just switching the x and y around. So the inverse should be 10, negative 9, negative 3, 1, negative 5, 8. Those are going to be free points for you on your quiz. If you mess that up, you're just not paying attention. So that's a freebie on your quiz. Well, not these numbers, different numbers, no. Okay. So this is, again, like I talked about at the beginning, categories. One category of problems that you're going to be dealing with is taking a function that's a set of ordered pairs and finding the inverse of it. Super easy. Okay. There's 2 other kinds of things that we're going to do in this section. One is we're going to find the inverse of an actual function, like an equation, and then we're going to determine if 2 functions are inverses of each other. Okay, so that's the 3 categories. 1 is a set of ordered pairs, 2 is find the inverse of a function, and 3, verify that 2 functions are or are not inverses. Okay? So finding the inverse of a function from a function. And one of the reasons that we even show you the one with the ordered pairs is the idea that the inverse, in general, is always just the x's and y's switched, exchanged. So even if I just have a function, if I just have an equation, we're going to do the same thing. We're going to exchange the x's and y's. And that's what this is. When you replace x with y and y with x, you exchange x with y. And then we just have to take it a little bit further, and that's what I'm going to show you here. So we're going to go through an example, because I think that's the easiest way to kind of get this figured out. Okay. So here is an example of an inverse, or an example of a function, and we're going to find the inverse of it. So we have to have a y and an x. Do I have a y here?
Yes.
What is the y?
-5.
No. F of x. Remember that this f of x really means y. So my first step is I'm going to rewrite the equation. I'm going to replace the f of x with a y. And you probably don't need to write this part down, since we already have it up here. Just rewrite the function so that it has a y instead of an f of x. Okay, that's just rewriting it. Now the second part is doing what it says up here. Right? We gotta exchange the x and y. So notice in the equation that's written there, I highlighted the x and the y, so you can see that they switched. It used to be y on the left and x with the 2, now they switched.
Does the coefficient go with it?
No, we're literally just changing the variables. Okay? So everything else stays the same. Right. Any guesses about what I need to do now?
Solve it.
Solve for what?
X.
Oh, do you?
We already have it. X is already by itself. Yeah, we gotta solve for y. So now we gotta get y by itself.
Plug in 0.
No, we're not plugging anything in. Okay? We just gotta get y by itself. Okay? So we just have to solve for y. So go ahead and do that. Get y by itself. Switch to the next slide and you're just gonna see at the top the function again. Okay, just because there's not enough room on the bottom here. What's my first move gonna be though to get y by itself? Add 5. I gotta get the
What?
before I can get the y by itself, I gotta get the 2y by itself. Okay? So the first thing I'm gonna do is add 5 to both sides. So those of you who started dividing by 2 right away, I mean you could do that, but think about how we try to solve equations. In order to get the variable by itself, we first get the variable term by itself. So simply we just added 5 to both sides, and then my next move is now I want to divide by 2. Okay? So you can separate it as x over 2 plus 5 over 2, but you don't have to. Okay? So one of the things that I know some of you get frustrated with fractions, you can leave it like that. That's fine. Once I've gotten y by itself, I'm really done. Okay? I've created a new function, but our notation has to change a little bit. Okay? So I'm going to replace the y with this function notation. It says f to the negative 1 of x. This does not have anything to do with negative powers. It doesn't mean move it down or anything like that. That negative 1 notation inside a function notation just means the inverse. So when I rewrite it, I'm signifying to the rest of the world that this is the inverse of f. Okay? That's what that notation means. The inverse of f. Even better, inverse of f of x. How about that? That's probably more complete. The inverse of f of x. So before I move on to the next problem and make sure that I'm done, we've got to take this step. So we're going to do that. Okay, so we flip this around, y equals x plus 5 over 2. Replace the y with the inverse of f. Okay, and so here's sort of a summary, this last little part. The inverse of f of x equals 2 minus 5 is the inverse of f of x, x plus 5 over 2. Not necessarily. Okay.
So can you just like break
So yeah, if you just wrote this, if it was asking you to find the inverse, and you just wrote that, that would be good enough.
Okay.
It is necessary that you replace the y, okay? This has to happen. So when we get to a quiz or test, make sure you replace the y with the f to the negative 1 of x notation. Okay, so in summary so far, we can find the inverse from a set of points. Just switch the x's and y's around. You can find the inverse from a function, from a formula, from an equation. Switch the x and y around, solve for y. Okay, so that's the other kind of thing you're going to do. The last thing we're going to do is verify whether or not two functions are inverses of each other. Okay? And that does not mean we are finding the inverse. We're going to verify whether or not two things are inverses of each other. And there's a very specific way to do that, and what we did yesterday is going to be used in order to do that. So this is the last part. Again, I want you to put things in categories. So the third category is verifying that functions are inverses. And it's possible that there's going to be a lot of steps to this. It just depends on our first step. If our first step verifies it, then we got to keep going. If the first step shows us that, hey, these can't be inverses, then we can stop. Okay. So here's the key thing. F and G are inverses if and only if. If and only if f of g of x equals x, and they both have to happen, g of f of x equals x. Okay. So when we create the composite functions, so this is what we did yesterday. We found f of g of x and g of f of x. What's important today is that if both of those composite functions equal x after you've gone through the whole process and simplified, then f and g are inverses. So you have to do both. If you do f of g of x and it equals x, then you keep going and do g of f of x and hope that it equals x, and if they do, they both equal x. And it has to be x, not negative x, not x plus something, not x to, it's just x. If that happens, then they are inverses of each other. So again, we are not actually finding the inverse of f and going, oh yeah, at equals g, so they're inverses. Nope, we're not doing that. We're verifying it by using composite function. So, you're going to start by finding f of g of x. So I'm going to give you the steps first, and then we're going to apply them. So this screen is all going to be like a recipe of what to do when you're verifying. Second step. Okay. Now here's the thing. So we go ahead and we find f of g of x. If it equals x, then you go ahead and find g of f of x. And the idea is if that equals x, then we know they're inverses of each other. Okay. So obviously there's one of two options here. Either f of g of x equals x or it doesn't. If it doesn't, they can't be inverses. And now I want you to verify that you did it right. You know, go back and look at it, because the thing here is we're hoping that they're going to be inverses. That's what we're trying to verify. We want to have success. But if it doesn't equal x and you're triple checked your work and you know it doesn't equal x, then they can't be inverses. So there's no point in even finding g of x anymore, because they can't be inverses. Okay, and so the other option is if f of g of x does equal x, and then we go ahead and find g of f of x, and g of f of x does also equal x, then we know that they're both inverses. Okay, now what's going to be important here is on your quiz and on your test, when you get to the problem that says verify the functions are inverses, you do all your work, f of g of x, you show it equals x, g of f of x, you show it equals x. You will have to write this. We know that f and g are inverses since both f and g of x and g of f of x equal x. So, I know that's a lot of math, seemingly math mumbo jumbo. Okay, but what I'm underlining here is your explanation. When you end up with a situation where f of g of x equals x and g of f of x equals x, that means f and g are inverses, and what I've underlined in red is your explanation. So you're going to have to show your work for f of g of x, you're going to have to show your work for g of f of x, and then you're going to have a statement at the end, a conclusion, stating why f and g are inverses. Okay, so that's really important. I underline that. That's one of those, make sure you write it down and sort of commit it to memory, because that's the explanation that I want. We're going to go through two examples, one where they are inverses and one where they aren't. So you're going to see exactly what I want you to write and how I want you to write it and explain it. Okay? So that it makes a little more sense. Now, I don't think we're done with these. No, I got one more thing on this. Okay. If g of f of x does not equal x, then again, f and g cannot be inverses. I will tell you that most of the time, you won't have one that equals x and one that doesn't. I'm trying to think of a situation where that could happen. I don't think it's possible. But usually, at this step right here at b, if it doesn't equal x, you're stopping, you're done. There's no reason to find g of f of x. Because if f of g of x doesn't equal x, then they can't be inverses, so there's no point in going on. I don't think there's going to be a situation where f of g of x could equal x and then g of f of x doesn't equal x. Okay? So if this happens, A in green, okay, then we're probably going to be in the situation C. I don't believe A can happen and D can happen. I don't believe that can happen. I can't think of a situation right now where it doesn't. That's why I'm sort of guarding myself a little bit, because I don't want to be I don't want to tell you something that might be wrong, but I cannot think of a situation where that would happen. All right. But like I said, we're going to go through an example of ones that are inverses and ones that are not, and so you'll see exactly what I want, what work I want you to show, and what explanation I want you to give. Okay? Are there any questions on this general idea right now? Again, this is the third sort of compartment, verifying that two functions are inverses. Yeah, this is the last one. Okay? All right, so let's look at an example. Okay, and this is what it's going to kind of look like. Determine whether each pair of functions are inverse functions. Explain your reasoning. Okay? So I've got f of x, 3x minus 3, g of x equals 1/3 x plus 4. What should I do first?
Find y. Plug in the y. Like,
Nope.
Plug in g of x.
what?
Plug in the g of x for
X.
x in.
F of
What are we doing?
Plugging in g of x into the x and f of x.
You said the first step was plugging the y.
No,
for f of
that
x.
was for finding the inverse.
Oh my
That was the
God.
second compartment.
You're gonna plug in one.
We have to find f of g of x.
You're gonna plug in 1/3 x.
Okay? Yeah, you're right. I just wanted you to say f of g of x. We're going to plug g of x into f. So we're going to find f of g of x. So go ahead and do that. And what we're hoping is that when we plug this in and simplify, that it's going to equal x. Okay? That's what we're hoping. Let's go ahead and do that. So, again, this is the application of what we did yesterday. Okay? So I'm going to substitute 1/3 x plus 4 into x in f. So this is 3x minus 3. I simplify, I distribute the 3, so I get x plus 12
I thought it was
minus 3.
oh, okay.
And so that is
X, 9.
x plus 9. Can I go any further?
No.
Okay. So, f of g of x does not equal x. There's no point in even finding g of f of x.
Perfect.
We don't need to keep going. It is not possible for f and g to be inverses because when I plugged it in and simplified it down as far as I could get, it didn't equal x. So I stopped. Okay? F of g of x does not equal x, therefore f and g cannot be inverses. What's in red there is your concluding statement.
Wait, what is x again? I'm confused.
It just has to equal x. See how there's
Right.
a plus 9 there?
Correct. This,
oh, okay, I see.
right. So this would have just needed to be x. But because it's not just x, it can't be an inverse. It has to equal x. And so that what's in red is your explanation on your quiz or test. That's your, so the work is the justification, is the evidence. What's in red is the conclusion. Determine whether each pair of functions are inverses. They're not. Because f of g of x does not equal x, which means g of f of x is not going to equal x 2. If you really wanted to go through and find it, you could. You'll find out that that doesn't equal x either. But there's no way they can be inverses unless they both equal x. Okay? So So that's the first example. Let me talk about, when we go through it, I'm gonna talk about why x is important, why it has to be equal x, and where the inverse kind of comes from. Because if you go to pre-calc next year, you're gonna do this. You're gonna graph inverses like crazy. So here's two more functions, okay? 2x squared, f of x equals 2x squared minus 1. G of x equals the square root of x plus 1 over 2. Alright? So, go ahead and find f of g of x. Go ahead and do that.
If you realize the square roots cancel out.
Just do f of g of x for now. Don't keep going. Just do f of g of x.
Do you have to simplify the radical portion?
No, it's all simplified.
I'm just gonna
2x
squared cancels out.
But I have a feeling when I get to the homework and quiz, they won't cancel each other out.
Well, then they're not gonna be inverses.
That makes sense.
Oh, amen.
So the idea with inverses is that, you know, squaring and square rooting are inverse operations. Okay, we had the 3x and the 1/3 x. Those are inverse operations. You should see that kind of thing happening in each function. They should have some inverse operations going on. Okay, so that's what it should look like when you initially start. I'm not going to do it yet, but this is your setup. I took g of x and it went into just the x. Okay, notice here the x is squared, so all of this gets squared.
Oh my god.
And so, yes, as some of you were saying, the square and the square root are going to cancel each other out. And it's going to make it a lot simpler. Okay?
The 2's cancel out.
So the first thing that happens is the square root and the square cancel. Now, right, J. Henry, you were right. The 2's, because this is like 2 over 1, those cancel as well. Okay, so then I'm just left with f of g of x equals x plus 1 minus 1, which means f of g of x does equal x. So that's good. Now I've got to keep going. Now go ahead and find g of f of x. It should also equal x now. Okay, so go ahead and find g of f of x. Yes, just because one of them works, you still have to prove it by showing the other one. You can't just go, oh, well, one of them works, therefore they must be inverses. No, you have to prove that they both work. Yep, so obviously we've already said that. Now find g of f of x. So here's the setup for the next one. So I substituted in here this x. I substituted 2x squared minus 1 in for that x. Okay, so that's what you should have done. You plug f into g. So, here's what we've got to keep in mind, all right? There's nothing being multiplied by this set of parentheses, so we can drop them. And so I'm going to do negative 1 plus 1. So I end up with the square root of 2x squared over 2. Now, the 2's cancel. I have the square root of x squared, which is what?
X.
X. Okay? So that's the work. I've proven that f of g of x equals x and g of f of x equals x. Now, if you remember on the recipe page, there was that last line in red, your conclusion. So now you need the conclusion. Okay? And this is the conclusion. Therefore, because both f of g of x equal x and g of f of x equal x, f of x and g of x are inverses. I would, it's a conclusion.
Well, like, it's like, that's like a full.
Am I going to take points off if you don't write the word therefore? No, I'm not going to
That
take
would
points
be
off.
a problem.
Because, like,
Let's put a bow on it.
I know
Again,
exactly
there are
what
3
this
things
is.
that you have to do in this section. 1, find the inverse from a set of points. Easy. Okay. 2, find the inverse from a function. Switch x and y, solve for y, replace with the inverse function notation. And 3, verify that two functions are inverses, and that's all of this that we just did, okay? Are there any questions?
Therefore,